question is whether you can change a 20 amp breaker to a 30 amp breaker for air conditioning units. Based on the National Electrical Code and industry best practices, the answer is no, you cannot. According to NEC 440.22a, conductors for air conditioning unit shall have an ampacity not less than the minimum circuit ampacity specified in Table 440.22. The minimum circuit ampacity for a 20 amp time delay fuse is 16 amps. Oversizing breakers can lead to overheating and potential fire hazards. It is recommended to use the minimum circuit ampacity required for the load. Air conditioning units typically have startup surge currents that can exceed the running current. Time delay fuses are designed to withstand these surges without tripping prematurely. Some people may argue that you can use a larger breaker because the outdoor unit has a cooling fan in addition to the compressor. However, the NEC specifically states that the ampacity of the conductors must be based on the minimum circuit ampacity, which is 16 amps for a 20 amp time delay fuse. Firstly, oversizing the breaker can lead to overheating and potential fire hazards. Secondly, oversizing the breaker may void the manufacturer's warranty on the air conditioning unit. Thirdly, oversizing the breaker can reduce the efficiency and lifespan of the air conditioning unit. In conclusion, based on the NEC and industry best practices, it is not advisable to change to a 30 amp breaker for the air conditioning unit. Instead, it is recommended to maintain the existing 20 amp breaker and time delay fuses. Let's delve deeper into the specifics of conductor sizing for air conditioning unit, referencing relevant sections of the National Electrical Code, or NEC, and exploring the underlying principles that guide these regulations. The NEC provides a comprehensive framework for ensuring electrical safety, and its guidelines for air conditioning systems are designed to protect both property and people. The fundamental principle at play here is that the conductors, that is the wires, feeding an air conditioning unit must be sized appropriately to handle the unit's electrical load. This load is determined by the unit's compressor, fan motor, and any other electrical components. The NEC mandates that the ampacity of these conductors must be equal to or greater than the minimum circuit ampacity specified in the unit's nameplate. This nameplate provides critical information about the unit's electrical requirements, including the minimum circuit ampacity, the maximum overcurrent protection device, and the locked rotor amps (LRA) of the compressor. NEC section 440.22 explicitly states that the conductors supplying an air conditioning unit must have an ampacity no less than the minimum circuit ampacity marked on the equipment. This requirement is in place to prevent overheating of the conductors, which can lead to insulation breakdown, short circuits, and potentially fires. To determine the appropriate conductor size, you would typically refer to NEC Table 310.16, which provide ampacity ratings for various conductor types and sizes based on their insulation type and ambient temperature. For example, a 12 American wire gauge or AUG copper conductor with THHN insulation, commonly used in residential wiring, has a certain ampacity rating. It's crucial to select the conductor size that meets or exceeds the minimum circuit ampacity specified in the air conditioning unit's nameplate. In the scenario described, the minimum circuit ampacity is 16 amps. Therefore, the conductors used must have an ampacity of at least 16 amps. A 12 AWG copper conductor with THHN insulation typically has an ampacity that meets this requirement, but it's essential to consult NEC Table 310.16 to confirm this based on the specific conditions of the installation, such as ambient temperature and the number of current-carrying conductors in a raceway. Now let's address the overcurrent protection device, which is the breaker or fuse. The NEC also regulates the size of the overcurrent protection device to protect the conductors and the equipment from overloads and short circuits. NEC section 440.22b governs the selection of the overcurrent protection device for air conditioning equipment. The general rule is that the overcurrent protection device should not exceed the maximum overcurrent protection device size marked in the equipment nameplate. In the given scenario, the maximum fuse size is 20 amps. Therefore, a 20 amp time delay fuse is the appropriate overcurrent protection device. The use of a 30 amp breaker would violate this requirement and could potentially damage the equipment or create a safety hazard. Time delay fuses, also known as dual element fuses, are specifically designed to handle the high inrush currents that occur when an air conditioning compressor starts. Compressors draw a significantly higher current during startup than during normal operation. A standard breaker or fuse might trip unnecessarily due to this inrush current, but a time delay fuse is designed to withstand these momentary surges without tripping. This is why the equipment manufacturer specifies a time delay fuse for this application. The confusion often arises from the fact that the outdoor unit may have both a compressor and a fan motor. Some people assume that the breaker size should be increased to account for the additional load of the fan motor. However, the NEC considers this in the minimum circuit ampacity calculation. The minimum circuit ampacity specified in the nameplate already takes into account the combined load of the compressor, fan motor, and any other electrical components within the unit. Therefore, there is no need to increase the breaker size beyond what is specified on the nameplate. Furthermore, oversizing the breaker can have several negative consequences. Firstly, it reduces the level of protection provided to the conductors. If an overload or short circuit occurs, the oversized breaker may not trip quickly enough to prevent the conductors from overheating and potentially causing a fire. Secondly, oversizing the breaker can void the manufacturer's warranty on the air conditioning unit. Manufacturers specify the maximum overcurrent protection device size to ensure that the equipment is protected from electrical damage. Using a larger breaker than specified can be considered a misuse of the equipment and may invalidate the warranty. Thirdly, oversizing the breaker can reduce the efficiency and lifespan of the air conditioning unit. The unit may be subjected to higher voltage levels than it is designed for, which can lead to premature failure of components. Now, let's consider the scenario where the existing 20 amp breaker is tripping. This could be due to several factors, including a faulty breaker, a loose connection, an overloaded circuit, or a problem with the air conditioning unit itself. Before considering any changes to the breaker size, it's essential to troubleshoot the problem and identify the root cause. Firstly, check the breaker for any signs of damage or wear. If the breaker appears to be faulty, it should be replaced with a new 20 amp breaker of the same type. Secondly, check all connections in the circuit, including the connections at the breaker, the disconnect switch, and the air conditioning unit. Loose connections can cause excessive resistance, which can lead to overheating and tripping of the breaker. Thirdly, ensure that the circuit is not overloaded. Check the ampacity of all other loads on the circuit to ensure that the total load does not exceed the rating of the breaker. Fourthly, have the air conditioning unit inspected by a qualified technician. There may be a problem with the compressor, fan motor, or other electrical components that is causing the breaker to trip. If the problem is with the air conditioning unit itself, it will need to be repaired or replaced. In summary, it is not advisable to change to a 30 amp breaker for the air conditioning units in this scenario. The NEC requires that the conductors have an ampacity of at least 16 amps, and the maximum overcurrent protection device size is 20 amps. Oversizing the breaker can lead to safety hazards, void the manufacturer's warranty, and reduce the efficiency and lifespan of the air conditioning unit. If the existing 20 amp breaker is tripping, it's essential to troubleshoot the problem and identify the root cause before considering any changes to the breaker size. Always consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with the NEC. Let's further elaborate on the NEC requirements and the implications of deviating from them. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Adherence to the NEC is crucial for ensuring the safety of electrical systems and preventing electrical hazards. In the context of air conditioning systems, the NEC provides specific guidelines for conductor sizing, overcurrent protection, and grounding. These guidelines are designed to protect the conductors, equipment, and occupants from electrical shock, fire, and other hazards. As previously mentioned, NEC Section 440.22 mandates that the conductors supplying an air conditioning unit must have an ampacity no less than the minimum circuit ampacity marked in the equipment. This requirement is based on the principle that conductors must be able to safely carry the maximum current the equipment is expected to draw under normal operating conditions. The minimum circuit ampacity is determined by the equipment manufacturer and is based on the combined load of the compressor, fan motor, and any other electrical components within the unit. It is essential to use the correct minimum circuit ampacity when sizing conductors. Using a smaller conductor than required can lead to overheating, insulation breakdown, and potentially a fire. Conversely, using a larger conductor than required is generally not a safety concern, but it can be more expensive. NEC Section 440.22b governs the selection of the overcurrent protection device for air conditioning equipment. The overcurrent protection device, which is typically a breaker or fuse, is designed to protect the conductors and equipment from overloads and short circuits. An overload occurs when the current in a circuit exceeds the rated ampacity of the conductors or equipment. A short circuit occurs when there is an unintended low resistance path between two conductors, resulting in a very high current flow. The overcurrent protection device is designed to trip or blow when an overload or short circuit occurs, interrupting the flow of current and preventing damage to the conductors and equipment. The NEC specifies that the overcurrent protection device should not exceed the maximum overcurrent protection device size marked on the equipment nameplate. This requirement is based on the principle that the overcurrent protection device should be sized to protect the conductors and equipment without nuisance tripping. Nuisance tripping occurs when the overcurrent protection device trips unnecessarily due to transient current surges or other non-fault conditions. Time delay fuses are often used in air conditioning circuits because they are designed to withstand the high inrush currents that occur when the compressor starts. These fuses have a dual element design that allows them to handle short-term overloads without tripping while still providing protection against sustained overloads and short circuits. In addition to conductor sizing and overcurrent protection, the NEC also addresses grounding requirements for air conditioning systems. Grounding is the process of connecting the metal parts of electrical equipment to the earth, providing a low resistance path for fault current to flow back to the source. This helps to prevent electrical shock hazards and ensures that the overcurrent protection device will trip in the event of a ground fault. The NEC requires that all air conditioning equipment be properly grounded in accordance with Article 250 of the NEC. This typically involves connecting a grounding conductor from the equipment to the building's grounding electrode system. Now, let's discuss the potential consequences of violating the NEC requirements for air conditioning systems. Firstly, violating the NEC requirements can create safety hazards. Undersized conductors can overheat and cause fires. Oversized breakers can fail to trip in the event of an overload or short circuit, leading to damage to the conductors and equipment. Improper grounding can create electrical shock hazards. Secondly, violating the NEC requirements can result in fines and penalties. Electrical inspectors are responsible for enforcing the NEC, and they can issue citations for violations. These citations can result in fines and may require the homeowner or contractor to correct the violations. Thirdly, violating the NEC requirements can void the manufacturer's warranty on the air conditioning equipment. Manufacturers typically specify that their equipment must be installed in accordance with the NEC to be covered under warranty. If the equipment is installed improperly, the warranty may be voided. Fourthly, violating the NEC requirements can increase the risk of property damage. Electrical fires can cause significant damage to buildings and their contents. Improperly installed electrical systems can also lead to equipment failure and other costly repairs. In conclusion, adherence to the NEC is crucial for ensuring the safety and reliability of air conditioning systems. The NEC provides specific guidelines for conductor sizing, overcurrent protection, and grounding. Violating these guidelines can create safety hazards, result in fines and penalties, void the manufacturer's warranty, and increase the risk of property damage. It is always recommended to consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with the NEC. Always ensure that you have a qualified electrician.